for joining in and being a part of this evening. This is Shruti Khurana on behalf of TCS iON. I welcome you all to this exciting Jobinar, which is a free masterclass on data processing using PySpark. But first, what is Jobinar? We are actually providing you a Jobinar-based masterclass today. TCS iON Jobinar is a program through which we reach out to you all and give a perspective about 360-degree view of about what's happening in the industry and in the job world. So this is actually happen every second and fourth Thursday of the month. So we hold such webinars and we hope we are adding a value to you in your search for a bright and rewarding career. So in today's masterclass, we will Spark simplifies data processing. Whether you are a beginner or someone with some programming experience, this masterclass will provide valuable insights and hands-on learning to set you on the right track of data engineering roles. As we go through this session, we will dive into the programming construct of Spark using PySpark, helping you understand structured data workflows. We will also explore how PySpark enables efficient big data processing, equipping you with tools to manage and analyze massive datasets with ease. Our goal is to ensure you not to only grasp the concepts, but also feel confident applying them in practical scenarios, giving you a solid foundation for future projects or career opportunities. So by now, you must have attended many masterclasses by our speaker for the day. Let's welcome Devashish. Devashish has been working with the Tata Group of companies for 18 years as a subject matter expert in diverse technical domains such as big data analysis, data engineering, cloud computing, and architecture, data science, artificial intelligence, machine learning, and many more. Data engineering skills he has conceptualized and created the hands-on environment on the TCS iON Cloud platform and has been mentoring the technology teams on other multiple projects. This is really wow. So welcome you, Debashish. Now, Debashish, I would like to hand it over to you. Please take us through the key topics we will cover today in the data processing with PySpark and share how each of these concepts plays a vital role in real-world data scenarios. Over to you, Debashish.
Thank you so much, Shruti, for this fantastic introduction and introducing us into this. See, what I will cover today is I will walk you through the big data concepts. That is the very basics of big data and the Hadoop itself. Then we'll go with Hive and understand a little bit of Hive itself, how Hive works, what are the different concepts of Hive SQL. And I'll walk you through the basics of PySpark programming and how we can connect like PySpark along with, say, Big Data Hadoop. Okay, how we can process using PySpark and connect PySpark with Hadoop itself. Okay, so that is what the takeaway is, and we will touch upon that. Okay, so coming to the basics of this big data concepts, I'll turn off the video just in case the bandwidth creates a challenge. So now these concepts, those who are absolutely new for them, these concepts would help those who are here to enhance your skill. Then for them, this is just a repetition, but you can actually recap along with me. So coming down with the big data concepts, obviously, you know that we are flooded with data today. Now, when we talk about data engineering, you know that we have to work, data engineers work throughout the life cycle of the data, starting from capturing the data, fetching the data from diverse sources, providing the data in a mechanism, creating the data platform in a mechanism so in such a way that the data analyst, the data scientist can actually use the data for further operations. So basically, all the intelligence systems today are fueled by the data. Now, data engineers' role would be to process the data, fetch the data, work with it, and create a platform where data can flow freely, and actually it can be provided to the context where it is required. Now, data is coming to us in different formats, in different speed, in different variety, okay, in absolutely in different ways, in such a way from diverse sources that it becomes very difficult to manage the data, store the data, and work with it. Now, any concept, like anywhere where the data managing, storing, collecting, analyzing becomes difficult, we call this as a term called big data. Why? Because the term big itself is relative. When we were actually, if you look back, when we had, suppose 1 GB of data itself was a huge thing, then that was big. Now today, even the terabytes is manageable, so it is not that big enough. We can also extend further over there. So whenever it becomes, so the term big is absolutely like a concept, or it is a comparative word that can be used and that can changes with the advancement of the technologies and the way we are handling it. But at any instance of time or at any instance of the period where handling the data becomes very difficult to manage and work with, to analyze and collect and store and preserve, we call that as big data. Now, big data handles data in all forms where the data can be structured, unstructured, semi-structured, and so on. Now, when we call about structured data, we talk about basically the relational database management systems, like where we have a tabular format when we want to store with it a fixed structure of the data itself. In a fixed format of the Excels, where we are using, suppose the tab table and the row and the column format, we call it a kind of a structured format, or the structure is fixed. When we call it an unstructured, that means the data can come in any format. It can be like the streaming data, it can flow in any format, and we have nothing to, we cannot control how the data would come. Okay. When we talk about the semi-structured data, then obviously when we say that the data belonging to the JSON or the BSON, or we talk about the XML, these are the examples of the semi-structured data. The textual data, today with the prompt engineering, the textual data can come in actually any different format, like a human readable format, I need to process it. So that is also a very important thing with the, suppose Gen AI coming into play. This plays a very pivotal role in natural language processing. So we all have to create platforms. We all have to process these kind of data in a way that it is within a feasible amount of time we can handle this. Now, Apache Hadoop and ecosystem. Apache Hadoop and ecosystem comes with a way that it says that it can manage data. Now, obviously, Apache Hadoop uses the concept of the file systems itself. So naturally, the way it is stored and processed, there are multiple architectures and there are multiple ecosystem tools that is associated with Apache Hadoop, which you can actually use them to process this data in the format that you want. The data is stored in the Hadoop, what we normally would refer as Hadoop distributed file system, what we call as HDFS, because, and it uses, in a very common term, it uses like a commodity hardwares. Commodity hardwares are normal machines which are in a distributed pattern. It is aligned. Now, the different ecosystem tools and the processes that you're using today, using the Apache Hadoop for processing of any kind of data, you would store it, the data would be stored specifically in the data nodes, and it would be the directory structure and all these things would be controlled by the name node itself. These are the components of Apache Hadoop. Now the Hadoop has multiple major modules, what we call Hadoop Common. Now Hadoop Common utilities support other Hadoop modules. It is what I was talking about, the Hadoop distributed file system, which actually provides distributed file system provides a high throughput access to the application data. That means you can actually interact using these HDFS shell commands with the directory structure, and the data can go and fetch from the data node and work with that. Hadoop Yarn. Yarn is for the job scheduling and cluster resource management. And Hadoop MapReduce is a kind of a way that data is being processed and stored using the two operations. One is called the map and the other is reduce operations. Now, as the Hadoop also evolved over the period of time, the Yarn also came into being, which is called the yet another resource negotiator. And it is used for parallel processing of very large data sets. Now, Hadoop distributed file system runs on commodity hardware. That is what I was talking about. It is multiple systems when they are networked and they're working in a distributed computing manner. It provides a distributed file system architecture which can store petabytes of data. Now, normally we say that HDFS is fault tolerant and can split across multiple systems to provide a distributed architecture. Now, when we say that it is fault tolerant, that means that obviously we have to provide for necessary backup. So these are replication factors of each file that is being stored. That is how even if one node goes down, it can be fetched from somewhere else. So data will never be lost. So the file system stores data in a redundant pattern following replication so that it would be easier to rescue the system from possible data losses in case of failure. HDFS makes application available for parallel processing. And name node is, there are two components. One is called the name node and the data node. As I was specifying, the name node maintains the file and the directory structure in Hadoop, and HDFS commands are used to interact with the HDFS itself. Now, saying this, if I directly come to this, that HDFS shell commands are directly used to interact. Now let us create a system, or let us work with a system which will allow us to do certain hands-on on this. Okay. And I'll show you how we can actually work with it. I will, from my last cloud session, masterclass, I specified or I showed you that we can create like EC2 instances. And from there, EC2 instances are like compute engines. I've logged into my EC2 instance. I've logged into my AWS account. Here we have certain instances or the EC2 instances over there. The moment a particular instance is running, you have a public IPv4 address that is needed. How to create an EC2 instance, I've explained it in my last masterclass. Now in this, what I'm doing is, as you know that we will need a PEM file. While creating it, I have stored a PEM file in my desktop. So I'll quickly go over there. I'm starting a command prompt. If I give this, then ideas.pem is basically one example of a PEM file. PEM file, obviously, this is the file that is there. The IPv4 address I've copied. To connect with this, what I need to do is SSH -i, the PEM file name, ideas.pem. I've given this name. Ubuntu Ubuntu is a username the IP address that is there. Now see, in this particular, I've connected to my EC2 instance. In this EC2 instance, now you know that this Hadoop is actually this in the EC2 instance, this is an Ubuntu machine where actually I would try to run multiple clusters of the Hadoop environment. Okay. Now see, one question I have seen that specifies there are multiple platforms. Yes, absolutely. There are multiple platforms where you can use Hadoop EC2. Now I'm using this as an example to set up. You can set up a complete cluster within your own personal system also. Okay. Or you can download Cloudera VMs, or you can use certain other, say, even Databricks support and other ones you can actually use their big data platforms. Now this is the one I'm using because this is where actually I've created a Docker environment where multiple clustered Hadoop has been orchestrated or bounded using the Docker itself. Okay. So what I'm doing is I've created one big data Spark folder. Now this is, what is the architecture? The architecture is within this big data Spark folder. I've created multiple Docker files which individually would operate as individual machines and setups. There is a Docker Compose. Now, how Docker Compose is used? Docker Compose works like orchestrating the different components of the Hadoop into one environment. That means binds and gives a feel of a distributed architecture working together in a well-coordinated fashion. Now remember, one EC2 instance means in one machine. I'm directly trying to make this as a distributed architecture by using this. If you only manually install Hadoop over here, then it will be the same node, the same local host you would be using. But I would be using this as a distributed architecture where different IP addresses would be used and different port numbers would be used. Okay, so in a single machine, I'm emulating a kind of a distributed Hadoop cluster where it is working. Now, if I come to this one, obviously I have a docker compose.yaml file. Now, if we come to this one, as I was mentioning, there is a kind of a Docker Compose file. We need to start this. Now, how to create a Docker Compose and how to create a completely Docker file and install, that would be a separate masterclass altogether. In this, my idea would be to run this cluster, show Hadoop commands, run Hive, show Hive commands, run Spark, program with Spark and connect. Now, getting back to this one then, if I want to start this, to start a kind of a cluster with using Docker Compose, I'm using this command called sudo docker compose up. This will start this. Now, once this starts, the environment, I'll leave this running. Since it's a distributed architecture, I'll have to create multiple I'll use multiple individual command prompts that will emulate my different systems working together. Now, that was to start the cluster. Now, here also again, I would use the same thing. The cluster is starting, it is working, that is fine. I'll copy the IP address once more. Okay, so now coming down to this one is I will use okay. So once it is running, what I would do is I would run the name node to connect with the HDFS commands. To do that, what I can do is I can run the Docker file. Since the cluster is already running, I will start the Docker by using the command called sudo docker exec -it, sudo docker exec -it, name node bash. So this will connect directly to my bash shell. Now, once it connects to my bash shell, where the name node is running at the cluster, that means this creates a container and it is running a container where the name node is, or the HDFS is accessed through. So now if I want to use my HDFS shell commands, that is Hadoop distributed file system shell commands, I can use commands like HDFS DFS -ls is to see what is there, and I hit an enter. And here, what we are doing is we are directly finding out some of that these are the files that is being stored. Now, if I want to create a folder straight away into this and store it in the HDFS, So simply the Hadoop distributed file commands would be see, there are multiple questions coming up. I hope these questions would be like are taken so that I can answer them all together once.
Yes.
So what I would do is now I'm using at this point is that HDFS, DFS or Hadoop FS, however you want to code. HDFS, DFS. I want to create a folder. It's a simple HDFS command, what we call a shell command. I'm creating a folder called /dir. It is created. Now if I run this command, which I used in the last -lsr, you see that the dir is being created as a folder into this. Okay. Now suppose I want to load some file into this folder that I straightaway created. Let me cat and create a file called emp.txt. Let me cat into emp.txt. And I want to specify some names. Say, for example, I'm giving over there as emp number, ename, sal. I'm just giving some dummy names over there. Some dummy data to provide. Okay, so now if I directly come to this one, I have saved this file. So if I give an ls in the local file system, you see that the emp.txt is there. Now I'm going to load this emp.txt into the HDFS or Hadoop distributed file system. Okay. So if I want to do that, then I can use a command called hdfs dfs minus copy from local. There are two commands, or there are many commands actually, but you can use two of them. One is either you can use -put, that is one way, or you can use copy from local. Yes, put you can put, that is what I said. Either you can use put or you can use copy from local, both ways. And I want to store it in dir. So there are, these are the commands. One is put and this. Now, the moment I stored it, what happens is, if I want to see the file, HDFS, DFS or Hadoop FS, however it is, and if you want to see -ls minus capital R, this is basically the switch to use recursively display from the file. And if you hit an enter, you see that the file now, the folder now comprises of that particular file that we created and we stored it over there. Okay, it is now in the HDFS. If I want to see this, I've been using HDFS, DFS. There is another set you can use, HDFS, FS, though not recommended. You can use -cat /dir /emp.txt, hit an enter. So this form gives you the file, this gives you the data that you used. So proves that the data has been stored properly over there. Okay. Now, as I was specifying that there are multiple replication factors also over there to store the data, and it is stored in that way. So this is a way where actually even when a node goes down, the data can be fetched back to us. Okay.
Till then, Devashish, we can take one question from the Khotia. He is asking, how can we leverage this in accounting domain work? Some examples, please.
Yeah. So see, naturally in the banking and finance domain, obviously is working with a huge amount of big data. And the entire data set can be a Hadoop setup, or a completely, as a data engineer, you can create a complete setup of the HDFS platform. Okay, either in the cloud, if you use GCP, Google Cloud, that is also perfectly fine. There's no problem. Or you use Microsoft Azure. I'm showing AWS, that is okay, but anything you can use. And the entire thing can be moved over there and stored. In fact, all of these, like the GCP, the AWS, the Microsoft Azure, all have their own big data platforms. Okay, they have their own big data platforms, but those big data platforms would be charging you based on whatever you are using. Okay, so those are built in. You can just click and store the data and work with that, but those are chargeable. If you set up like this and create your own setup, and as a data engineer, I would recommend that using the vendor provided big data platforms, you can create your own. That will give you more control, more flexibility than the, say, vendor managed big data platforms. But if your company manages it, it is perfectly fine. It is also okay to use those things. It is easier though, but this is, as a data engineer, you would be knowing from the grounds up how you can work with it. Now, the entire banking and finance data of your company and all can be stored in the big data platform. And there you can analyze and use like the latest tools and technologies to actually work with it. Okay. Say, for example, in AWS itself, there is a platform called AWS EMR, that is Elastic MapReduce. That itself can be used, and it's a completely managed service, like you use it for Google GCP, or you use it for Microsoft Azure. Okay, so whatever domain you are using, be it banking and finance, medical, healthcare. Okay, healthcare also uses it multiple in different industries. So big data platforms and storing and working with this huge amount of data is essentially required. Okay,
Yes,
hope
yeah.
that clarifies.
Yeah. Devashish, now Agastya is asking, what is the difference between Kafka and Hadoop?
Yeah, coming to this one. Now the thing is that, see, Kafka, you can say that it will be used for the streaming data. Okay, when you have a completely streaming data coming to you, Kafka can be used as a kind of a publish subscribe model, what we call a pub sub model, where actually it will be publishing the data and you can use it on a like a streaming, say, pipe mode, the pipeline mode of a publish subscribe. You can use it for the Kafka itself. So to handle the streaming data, you can use Apache Kafka. Also, Kafka Confluent is another way you can actually work with in a web-based platform for handling these kind of data. And you can also manage and work with it. That also deals with a part of the big data. Now, Apache Hadoop also, you can configure Apache Kafka. If suppose I would thought that, okay, I want to use Apache Kafka and configure it in my Docker Compose, I could have done it. Then you could have actually seen that Kafka or Flume is directly interacting for streaming data on the Apache Hadoop platform. Okay, so these are parts of the ecosystem tools I can tell you.
And on behalf of Docker, Vikas is asking why Docker and Ubuntu is required.
Right. Very good question, actually. A very pertinent question, I would like to say. See, Ubuntu I'm using because big data platforms, normally Apache Hadoop and all works with Ubuntu, means a Linux based. So you can use Ubuntu, you can use Alpine, you can use any other Linux server, that is all okay. But if you are using a Windows server, then support is there, but it is preferred that you use a Linux based server for the ease of operation. That is one. Second is you can use RHEL, that is the Red Hat Enterprise Linux. That is also perfectly fine, or any other CentOS or any other variant. Now, why Docker is used? That is what I started with. The thing is that Docker is required because I'm using a single machine. Okay. One instance of EC2. If I have used multiple EC2, I could have actually avoided Docker, but that would have increased your infrastructure cost. Now here what I'm doing is I'm emulating the behavior. I repeat, I'm emulating the behavior of distributed architecture on a single machine. That is why I'm using Docker, where each container is running a separate, running as a separate machine with a separate port, IP, and a separate set of activities. Say, for example, the container where HDFS is running And where Hive will run, both are not same. Where Spark machine will run are not same. That is why I'm opening multiple windows, multiple command prompts to interact with it. And who is orchestrating this? The Docker Compose file is orchestrating between all these activities. Is that, see, data engineer's role to set up and to pave the path of as a fuel to all like software engineering and like the data scientists and data architects and the data scientists and the data visualization engineer to work with is a very complex task, but it is a very challenging and an interesting task with multiple job opportunities over here. One thing you understand, please be very sure of this. If this is an easy task, then anyone can do it. If it is a specialized task, then you have your requirement. So this is the choice. You want to go for an easy task where everyone is doing and compete, or you want to stand out and be one of a type which will help and use the data engineering platform for others to use it. I was talking about, before getting to this, I was talking about that we have a replication factor for this. So how do we see a replication factor? For that, multiple commands are used. Say, for example, if I use, okay, I logged off. I'm using the same command, say, for example, okay, hdfs dfs minus ls minus r, sorry, minus r slash dr. Why I'm giving, okay, so I think the other thing also got stopped. Just 1 minute. Yeah, that is fine. JPS will not work here. It's a distributed architecture. JPS works for your normal. I'll just run this once more. JPS will work when you're working with a single installation straight away, not on a Docker. Now I'm stopping the server and restarting it once more. So sudo docker compose down. And I'll restart this once more. Okay, so then I'll again get back my servers ready. Okay, so I think this is fine now. Once it is fine, I should be getting my HDFS. Once it starts running. Okay, sudo docker exec minus it name node bash to start the container. So now we are into this. The container is running. I will test the HDFS DFS. Now, since I stopped and I started, there can be some challenge with the file, but let me see. It removes when it stops basically. So if I give a ls command, so I'll quickly create the emp txt file because I've removed whatever was running. Okay, so okay, in DI or DR was already there. So if I give a HDFS DFS minus LS slash. Okay, so the DR folder was already maintaining in the Hadoop itself. That is the HDFS, the folder was there. So if I give DR over there, then this file should also be there. Yeah, so emp.txt is already there in the HDFS. From the local file, it got removed actually, but not from the Hadoop. So anyway, what I can do is now, I can directly quickly look into the recursive, like the replication factor. If I was talking about the replication factor before the first poll. So if you want to see the replication factor HDFS DFS, suppose I'm writing over there as a command called ls. I'm using this, and if I specify, say dr, then I've seen this particular file. So suppose I want to see the statistics. %r /dr/emp.txt. Now if I hit this enter, it sees that the replication factor by default is 3. Okay, that means there are 3 copies of the same file being made. So even if one node is down in the data node, it will all have a backup. So this proves that the fail safety that it provides for the data in HDFS. Okay, now keeping the data at this point here, I'll quickly run through Hive. Okay, because I have to continue all these things within just 40 minutes more. So I'm running through Hive. Otherwise, there's a full power packed HDFS shell commands you can play with. Now, if I talk about Hive, now what is Hive? Those who are comfortable writing SQL queries. Okay, those who are comfortable writing SQL queries like the select star command, okay, the DML, DDL, and the DQL operations of structured query language, and want to work with Hadoop. For them, Hive is a boon. Okay, so it provides a SQL layer on HDFS. It is useful for database programmers comfortable with SQL. Hive is a data warehousing infrastructure based on Apache Hadoop. Hive is designed to enable easy data summarization, ad hoc querying, and analysis of large volumes of data using HiveQL, what we call HiveQL, which is SQL-like operation. Okay, and also it allows the user-defined functions as well. Okay, like the PL SQL functions, it also allows to create the user-defined functions. Now, Hive normally is not used for online data processing, online transaction processing, including one node at a time, one data at a time. Normally, we don't prefer it. It is not that it is not cannot be used, but normally we don't prefer it because the main operation should be in a batch mode where it is a data warehousing application where a huge amount of data needs to be stored. So we prefer to use Hive and upload the data at this point like that. Okay. So in order of the granularity, Hive data can be stored or organized into database tables, partitions, buckets, or clusters in that way. Now there is the Hive. There is one important part you need to understand that although we are working with Hive, like the SQL operation, the data itself is stored in HDFS. I repeat, the data is stored in HDFS. What Hive manages for the SQL part is a kind of maintaining a metadata for which it uses a relational database. Okay, I repeat, Hive stores the metadata in a RDBMS and the data itself is stored in HDFS, okay, of the Hadoop. That is the architecture. Now, by default, there is a database for the standalone, which is called Darby, which is stored in, and the data is stored in HDFS. But if you want to say that, no, I don't want to use Darby, but I want to create a MySQL and align MySQL for Hive to work with, Obviously, you can do that, and very well actually in real life scenario, we create databases like that only. Okay. Now, obviously, we can use multiple SQL operations to work with Hive. So let us see how Hive can be worked in the environment that we created. Now, in this case, again, if I have to run another container, I'll have to start one more time, another command prompt. So what I want to do is now, again, SSH minus I, IDS.pem, and then the IP address I need once more. Copy the IP address. Username Ubuntu @ and then the IP address. Hit and enter. Now here I will start the Hive container. Okay, so how do we do this? Sudo docker exec -it hive -server bash. So it will launch you to the bash shell and the Hive container is running. Now say for example, you can start Hive as a command prompt, or you can start the thrift server if you want to program it and pass the data using Java or any other language, or you can open a Hive, or you can write down a SQL file and run the Hive over there. Okay, say for example, I'm running the Hive prompt. Now, as I was telling you that the moment you're working with Hive, the database, if you want to see the databases, if you want to clean the screen, Control L is okay, good to go. If you want to see the databases, there will be a default database by default. Okay, default. If you want to create a database, see how simple it is, like a MySQL, it is working. But actually, these are commands which are actually relevant to Derby, because Derby is validating these things. So create database, suppose test, sorry. Okay, database spelling error, database, Control L once more. Here was the mistake, A missing. So create database test, and it came back. Now if I say that show databases, and if you hit an enter, you'll see that okay, default and test. If I want to use test like MySQL, so it is now I would be creating tables. Now suppose I want to create a table called EMP that maps. So I will use, say, create table. Now see if there are no tables over there. So if I want to create a table called create table, if not exists, so that you don't recreate it or overwrite it, if not exists, command is used. Create table if not exists, I am specifying the name as EMP. Suppose I want to give EMP number, ename, sal. Okay, now this EMP number would be integer. So the data type I'm trying to give is integer. Ename would be string. So I would specify over here as string. And the salary I've created is integer. So it will be integer. I would specify a comment, though it is optional. I'm writing over there as employee records or company records, whatever you want to do. This is optional. Now you can specify how the data would be stored and preserved. You can mention row format, delimited fields, terminated by comma. See, if I use any other delimiter, you can specify it that way. So the data is stored in which format? Stored as text file. So if you want to store the data in a JSON format or any other format, you could have actually mentioned it. Now here the file is being created. If I want to specify describe, so describe command I am using, and I am using EMP over there. Now see the describe, it is being created. Now say for example, if I want to use after the describe in the prompt that I want to load this data from HDFS. I repeat, I want to load this data from HDFS. Now if I want to load the data from HDFS, there is a command. I'm using Control L. See, before loading the data, if I write, that is select star from EMP and hit an enter, E capital, and hit an enter. So directly gives me this. Okay, there is no data record. Now if I specify load data, which would be from the HDFS, load data in path. Now the thing is that if I give local in path, then the file should be in the local file system from where I'm loading. If the file should come from HDFS, the data is stored in HDFS, then I use load data in path. And I need to specify where it is. Suppose dr, and I've mentioned it as emp.txt. Into table emp. And hit an enter, the data is loaded. Now this is what I'm saying, the entire data is batch loaded. Now this one, you're not understanding because it is looking like simple. Now when the data itself is in a petabytes or terabytes and it is going or running in a batch, and I'm writing down a shell script to actually load several files at the same time, one by one, it will keep on processing the entire night. You will understand the volume and the strength of this architecture. As of now, it is looking like what is it? We can do it with SQL also. But no, the moment the volume comes into the picture, things and the dynamics would be totally different. So if I now come to this select star from EMP and hit an enter, you see that the data, we are preserving it. Now see why null in the first column, because it is treating everything as a data, right? And obviously my integer fields cannot store string values. So hence it was null. Now this is my Hive coming into the picture at this point. Now let us move into quickly to Spark and see how we can code with this. Okay, that is a programming part using PySpark I will be talking about. Coming to the part of the PySpark programming. Yes, you can specify that. Now, coming to the PySpark programming, Apache Spark obviously provides you a unified analytics engine for large-scale data processing. It provides high-level APIs, like for the Spark, it is giving you an analytics engine for large-scale data processing. Obviously, Spark operates in a distributed pattern, where a data itself can be stored in a distributed format. It provides the map and the reduce in a very fine way in the distributed architecture. It gives you the high-level APIs to work with Java, Scala, Python, and R as an optimized engine that supports general execution graphs. Now, ideally, what we use is we use Python because that is the most common that is being used. But obviously, you can code Spark programming using both Scala as well as Java and R as well. Okay. But normally Python Spark together, when we call it as a PySpark, is increasingly gaining its, the importance and the market captivity, I would like to say. So PySpark is on the go. It supports rich and higher level tools called Spark SQL. Okay, Spark SQL, it will enable you to create a data frame and you can actually interact with that and have a multiple query like you do for normal pandas operations for SQL and structured data processing. And if you want to use machine learning operations straight away, then mlib is the library that you can use for machine learning straight away using the Spark. Okay. Now, with this, you can use regression, you can do classification, you can do all sorts of processing, the text processing, the machine learning, you can do using the mlib library using Spark. The entry point, obviously, we can work with or create a Spark context, a Spark config, and the entry point for all functionalities, as we call, is a Spark session. So to create a basic Spark session, we can use Spark session.builder, and Spark session applications can create data frames and from an existing RDD, okay, that is a resilient distributed databases, from a Hive table or from Spark data sources. Data frame provides a domain specific language for structured data manipulation, what we can use both in Python and R. Okay, now let us see how Spark works, and let us try and create a connectivity using Hadoop and Spark programming. Okay, and see a very basic program how we work in this architecture. Now before that, let me show one more thing. Whenever you are trying to connect to the HDFS or Hadoop, there is one thing that you need to know, which port the name node is running. Because see, in a distributed architecture, however you're coding, the ports can also change. Although in the Docker Compose, we specify this and it follows, but it is always good to see which port it is running. So you have to understand which port the name node is running. So go through it and see that name node has been booted in which particular port itself. See, name node, it is starting in 9000, okay? It is creating the HDFS name node as 9000. Can you see this? So the moment it is specifying that it is using the name node in the port 9000, that means whenever we are connecting with HDFS, whenever we are connecting using the programming using Spark, we need to specify the node, the port number as 9000. Okay. In many cases also, you will see that it is not 9000, but it can also change. Suppose 8020. Okay. So it depends upon how you configure it. I'll use 9000 for this coding so that we don't, this connects to the name node. I need to use another command prompt to start the Spark master. Now in this again, I need the IP address, copy the IP address, SSH -i, IDS.pem, Ubuntu @ hit and enter to connect. So this is another machine. You can say I would start the sudo docker exec -it. Now I would specify spark-master, spark master bash. So we are into the Spark. Within Spark, if you see, this is the Spark. Now, whenever we are writing down a program, say for example, I want to write down a Python program, okay, that for the Spark, and this has to be executed by Spark to connect. So we need to use Spark submit for this. So you need to know where the Spark submit.exe is to run this. So if you go to cd Spark, then you see that ls there is a bin, cd bin. You see that there is Spark submit. Okay, that is PySpark, Spark submit, Spark art. All these related tools are there. Beeline connecting to the Hive. All these are here. Okay, so we'll use this path to directly connect. Now I will create my first program, a very simple program that I will create. Now what it will do, it will connect and it will get the data from HDFS, the file that we created, and it will display the records. Simple as that. Okay. So to do this, I will use vi command. Okay. So I'm using a code called vi first.py. That is a Python. If you install Nano and other editors, you can obviously use it. That is no problem. If you want to say that, no, I'm not comfortable with VI, I want to write it in a notepad, then also you can write it notepad outside and you can transfer that file to this container. That is also perfectly fine. Okay. Now say, for example, I want to code. So in VI editor, we start with I for the insert and start with this one. So from PySpark, import Spark context. That is a starting point. From PySpark, import Spark conf. Second part, conf equal to, what I'm doing is Spark conf, I'm initializing dot set app name. Although this is not mandatory, but I'm doing it first. Now Spark context I need to set sc equal to Spark context. Now these, as you can understand, when I'm just writing down a class name and I'm straight away specifying without any reference, these are static. So Spark context equal to conf equal to, I'm passing the configuration I created in the previous step. Now see, there is one thing I would do, sc.set log level. Now why it is important to set log level? It is good to set log level because, and I want to set this to errors only. In that case, what will happen is unnecessarily it will not run for all information. It will not bug us. Otherwise, it will keep on giving all messages if the log will be dumped. Since I'm using the, I'm not using any ID, but I'm using this terminal, it will dump all information, warning, everything over there. So only the log level I'm setting to error. Now suppose I want to get the file, the data itself. So records, okay, lowercase, records equal to, suppose I'm specifying sc, the Spark context.txt file. Now I want to read this from HDFS. Okay, so HDFS : name node. I've shown you already that it is in 9000 running. That is where 9000 is coming from, /dr/emp.txt. Now this one, the records will be all dumped over here. Now if I want to read this, I will use emp-rec equal to, I'll use the collect, that is records.collect. Now these are actually commands of the libraries in Spark. Once you go with the entire library over there, you will understand what collect does, how we can work with this, and what are the different programming parameters over there. So for individual, say, again, what I would do is I'll run the sudo docker exec -it spark -master bash ls. Okay, so the program is gone. I'll rewrite this once more. vi first.py. I was writing this. Insert again from the beginning, from PySpark. Now this time I'll speed up a little. From PySpark, import Spark context. From PySpark, import Spark conf. Now configuration, if I want to specify a configuration conf equal to Spark conf, creating an instance, set app name. Although, as I mentioned, this is not mandatory, but I'm doing it. Spark context equal to Spark context. Here in the parameter configuration, I'll pass the configuration that I created in my previous step. Now I was talking about the log level, sc.set log level. It is important because since I'm using the terminal, it will keep on giving me warnings and information and everything. So I'm setting the log level to error only. Now what I need to do is I need to read the lines. So if I write data equal to, I will specify sc, that is Spark context dot text file. Now in the text file, what I will do is I'll specify hdfs / name node. Now here, after the name node, I will specify 9000. See, remember the 9000 is the port that we have seen earlier. I showed you before starting this. And the file name is emp.txt. Now if I want to specify that is records equal to data.collect. Data is here just a variable. Collect is the method. Now for our emp rec, that is individual records, in recs, that is from the record list actually. I want to print the records. So I'm using this emp rec one by one. So this will just display. Okay, now at this stage, let me check that whether actually it could connect to my HDFS and print the output or not. So escape :wq dot enter. Now if I give an ls, the first.py is there. I need to run this. To run this, how do we do it? I showed you in my previous while I logged in that the Spark submit is under .spark bin, and then the Spark submit is over there. So you need to go to that level. And then you specify over there as first.py, okay? first first.py. That is the name I've given. Let's see what it does, whether it runs, connects, displays. What I did was I created the first app name connectivity, and when I'm reading with the HDFS, I use 9000 as the port because I explained clearly that 9000 is the port where the HDFS is running. And then I've collected it and displayed the file. That is my intention. So I'm saving this wq not. Now if I want to run this, I can run this as /spark /bin. Then within this, there is Spark submit. And within the Spark submit, I'm specifying the file name as first.py, and I need to enter this. Okay, so here you see the data is being fetched from HDFS. My network actually stopped me here just before fetching. And this was the only thing that was remaining actually to fetch the data. So the code that I wrote actually could fetch the data from HDFS, and it is being displayed. Okay, now had it been a kind of a very, like say for example, a large file we could have coded. It's a very basic program I just fetched and displayed. I could have added some queries. I could have created a Spark, I could have used Spark SQL, and I could have actually created a data frame and displayed or use an RDD to work with that and convert an RDD to Spark SQL and use various manipulative like Spark SQL manipulations with multiple frames and all to work with it. So that is how it actually would go on when you would go through this course, and eventually Spark ML or Spark machine learning you would be using to come across and to train a model, create a model, Along with that, in a data engineering, you would use what you call as an ML flow, okay, to track the entire thing that is working, and Kubernetes to actually map the distributed nature and to see how which node is up, how it is working, and so on. Okay, so that is the entire architectural flow that goes. Hadoop is providing you with a kind of a complete ecosystem framework for handling big data systems. Okay, now this was launched by Apache, what we call Apache Hadoop, and it is not a single tool, but it is basically using multiple ecosystem tools over there. Apache Hadoop, as I mentioned in the very first slide, has 4 major modules to work with it, where the architecture being used using the yarn Hadoop Commons, okay, Hadoop distributed file system is being used with commodity hardwares where they are actually enabled in a distributed fashion to store the data. Now, all the ecosystem tools of Hadoop, if I want to mention, then it can be like the MapReduce is the main thing, which will enable you to store the data in a more like a formatted manner. Okay, then there are tools like Hive. I demonstrated Hive. There are tools like, say for example, you can say AgeBase, which is a NoSQL database you can associate with that. Someone mentioned about Kafka, where you can work with Kafka for streaming the data or working with streaming data. You can work with Hadoop, say HDFS or Hadoop Scoop, Apache Scoop, which will work with transferring of large RDBMS files straight away into the data ingestion techniques into the HDFS. So these are all the tools and the technologies which work in coordination along with this entire platform. So together, the idea is to manage, store, collect, analyze data, which is absolutely beyond the capacity of certain hardwares to manage it normally. Okay, so that is where the big data thing comes from.
Asking a last question that is from Sachin. Is there any other platform also where we can use Hadoop instead of AWS EC2?
Yeah, absolutely. You can use many of these platforms provide their own Hadoop managed systems, like big data systems of their own. Like say, for example, if we talk about AWS, then Amazon, say EMR, Elastic MapReduce has its own. Similarly, GCP, Google Cloud has its own. Databricks has its own. Cloudera have its own platform. So multiple platforms are present, but these are all paid. And if you are using a vendor managed big data platform, then obviously you will not have like minutest control over yourself. Similarly, Hortonworks is another, Mapr is another. So there's no end to it actually. So if you are developing a Hadoop system over here, like the one as a data engineer, your role would be to create the data platform, okay, for your entire organization, entire system, and to work with the data in a way that it should be granularly, you have the granularity of the management of the data itself and to the extent that you want to work with. So for that, I would recommend that you know how to actually install, configure instead of manage services, and master the big data platforms as well as working with it, and a data engineering and as a data architect, you need to understand all these things. Someone also asked, is CI/CD a part of it? Yes, CI/CD is also a part of this entire process or the journey along with the Docker and all. Similarly, like a part called ML ops, machine learning operations, or a data ops, that is also a part of this entire data engineering journey when you are creating platforms, working with it, and analyzing the same. Now, the Spark gives you the analytics engine to directly work with it in a distributed fashion, which works very well in this, but fits very well in this entire scenario. So I took this attempt to actually show you what a Spark platform and how you can configure it using a Docker and coordinate between a HDFS and a Spark in a unified fashion and work with that. Okay, so that is how the idea was.
Thank you so much, Devashi. And today I would like to thank you so much for this special enlightening session, and also to our audience for their time and presence on today's webinar.
Thank you so much. Thank you so much.
Thank you so much.
Thank you, Shruti.